Okay, I'd like to do a few problems that were assigned for homework. I'm not going to go through always the math on each one, but I'll show you how to set them up. So the first one is number 8. I'm going to try one of each type, okay? Number 8, it says the sum of two numbers is 25. Okay, so again, with these types of problems, the sum of two numbers is 25. So it could be 20 and 5, 19, 6, 18, 7, x and y. Two numbers is 25. We don't want two different variables, so we solve one in terms of the other. So isolate x to be 25 minus y. So then you can say the same type of thing. X plus, right? Replace our x with 25 minus y. So 25 minus y plus y equals 25. Now, the sum of the reciprocals is 1/4. Reciprocals, you remember, is when you flip the number over. This is 25 minus y over 1, so a reciprocal would be this. The sum of their reciprocals is equal to 1/4. That would be how you would set that problem up. Now, I'm not going to go through the math of then getting rid of the denominators. You can do that work. That's the same as section 614 and check the back of the book. I just want to at least try to get some set up for you. The next one I'd like to try is number 10. Number 10 is not great coming out and saying to you that it's a distance, rate, time one, but in essence it is. So we're talking about a French club collecting money for students to go on a trip. When 6 students cannot go, each student's going to be charged $6 more because it'll cost more per student then. See, that's how it's a rate. When you talk about per, how much you're paying per student, that's considered a rate. So with this type of question, I again want to go back to my fake numbers. And let's talk about, since so many of you are going on a band trip next week, if there were 100 students going and the cost of the trip was the whole trip, let's say, cost, well, let's go with an easy number. The whole trip cost $500 to go. And let's say there was 5 students going. How much would each student owe? You would do $500 in total divided by 5. You would each owe $100, right? 500 cost divided by 5 students would be $100 each. Well, then let's say one person dropped out. So instead of there being 5 students, now there's down to 4. But the cost is still $500. You paid that money up front. But now one person can't go. So now all of a sudden, you and your friends, there's only 4 of you, you're going to have to take the $500 and divide it between 4 people. And it's going to be $125 for each of you. So the cost increased by $5. So those were fake numbers with real numbers, something that's relevant to your life. Let's try this one now. It says this cost of the trip was $540. And when each student could not go, they were charged an extra $3 each. Okay? So how are we going to bring this into our problem that we used before? Okay, so what we need to figure out here is, because we don't know how many students were going on the trip to begin with. All that we know is that, like what I said, we would take the cost of the trip divided by the number of students. So let's just break this down into original cost. Oops, original cost. I'm going to use words here for a minute. The original cost was $540 per student, we'll say, per student. So you would take the total cost of the trip and you would divide it by however many students were going, because that's what we did, right? We took the 500 that I gave you with a fake number and divided by 5 students were going. Each student paid $100. So we do the same thing here, but we don't know how many students were originally planning on going, so we're going to call it X. That would have been their original cost. And now I'm going to say I have a new one called the new cost per student. Well, we know that $540 is fixed in stone. We can't do anything about that. We owe it. But some students dropped out. Instead of the 5 that were originally there, like that's the one fake number I used, but whatever number it was, 5, 10, 15, 20, 30, now it's saying 6 are not going. So I'm going to take my original number of students and subtract 6. So the way we did it, we had originally our cost was, in my fake example, with my fake numbers, it originally cost me $100. Then when only 4 students went, it cost me $125. I was paying $5 more per student. Well, on this problem it says $3 more. But in order to get that $5 that I got, I took the cost, subtract the original cost, because that would have been cheaper, right? This is more expensive. Subtract the cheaper. So I'm going to take my 540, the cost when there was less students going, and subtract the old cost when X students were going, and that's going to give me $3. I'm paying $3 more. Just like in my fake problem. Originally I was paying $100. When one student dropped out, I was paying $125. 125 subtract 100 would be 5 in my fake question. Same thing here. Cost for the new cost when students dropped out, subtract the original cost per student is $3 more per student. It's a rate question. And you can go from there on solving it. All right, the next one that I want to try, that's another rate one, is number 14. Two kayakers paddle 18 kilometers downstream with the current in the same time it takes them to go up 8 kilometers upstream against the current. The rate of the current is 3 kilometers an hour. A few things you need to know here for those that don't know currents. So when you're driving your bike or running or paddling or anything that involves you going against the wind or against the current, when you're going against the current, it's harder. You have to use more power with your legs, or you have to paddle harder because the current is pushing against you. But when the current is with you, it's like, whee, going down a hill. The current is pushing you along, it's helping you, it's making you faster, in other words. So the few things that will help you figure out this problem. First of all, I'm going to put some words in. It says, they paddle downstream in the same time it takes them to go 8 kilometers upstream. Okay? So let me just write this down. Time to go downstream is the same, equals time to go up. Upstream. Now I just need a way to represent that, those words, in an equation. Time. Time should now be clicking into that it's distance divided by rate. Okay, so again, it might be helpful to use a little chart. So let's put downstream and upstream. Now we put our letters in again. Distance, rate, time. So on downstream he was going 18 kilometers. Upstream he was going 8. Says it in the problem. Now when you're going downstream it says with the current. That means you're getting a push. And we know the current is 3 kilometers an hour. But we don't know what your original speed would be if it was just still water. What you're paddling at. The current is what the river is doing. So if you, let's say you were paddling at 10, the current is helping you, you're now going 13 kilometers an hour instead of just 10. But we don't know the current, what he's paddling, so we just call it x. All we know is that he's getting a push of 3 kilometers per hour. But upstream, for a guy going upstream is having to really paddle, and the current is causing him to go slower. So how do I express time? Well, it's distance divided by rate. Distance divided by rate. And since I have this little visual up here to help me figure it out, now I know how to set it up. The time to go downstream is equal to the time it takes to go upstream. And that's for you to solve by getting rid of the denominator and so on. Okay? Now, there's one more that I wanted to try with you. So I'll leave for, it was number 16. It's quite wordy. Several cows from a herd take 4 days longer to travel 70 kilometers to Ford Lake than it took them to travel 60 kilometers beyond Ford Lake. They averaged 5 kilometers less before Ford Lake because foraging was better. What was our average speed for the part beyond Ford Lake? All right, so again, this is one of those ones, like I said. I'm going to Summerside in good weather, an hour. Bad weather, 2 hours. If I subtract bad from the good, I'm taking 1 hour longer. Same thing here. He's doing foraging was better and foraging was worse. Took 4 days longer. Now my only issue here is that we're talking about 4 days, but our rate is in hours. So let's just see if we can set this up in words first. So if I'm looking at my Summerside example, the time when it's bad goes first, and I subtract the good to give me how much longer it takes. So let me just write that in words. Let's say time when foraging is bad. Because it's going to be slower. Subtract time when foraging was good. Oops. Time when foraging good. And that's going to equal 4 days longer. Well, 4 days, and there's 24 hours in every day, is going to give me the 96 hours. I'm going to change that to hours right now. 96 hours longer. Now I just need a way to convert this into, well, we know time is always expressed as distance over rate. Distance over rate. Again, a chart is very useful here. One of these charts, foraging good, let's put good and bad. Good, bad. But you're noticing that a pattern is starting to develop. When foraging was good, let's see, several cows took them to travel, then it took them to travel 60 kilometers beyond. Foraging was better before Fjord Lake, okay? So 70 kilometers was where the good foraging was, before Fjord Lake. And 60 kilometers beyond. So this is the bad one, bad foraging. Okay? Now our rate, so I put distance, rate, time. Okay. They averaged 5 kilometers per hour less. So their speed was less, but we don't know what their cow's speed was, so we call it x. But we know they were 5 kilometers less. And this was just plain x then. And the time was just our little equation there, 70 divided by x minus 5, and 60 over x. And now I know what to do. How do I set this up as a final answer? I take the bad one, oh, sorry, now this is a little bit different than the bad weather one, right? Because when foraging was bad, that's when they were faster. The foraging is when they were stopping to eat. So this should be first then, the good one. Time when foraging was good, because that's when they're slower. We always want to do the slower one first. And this is when foraging was bad, because that's when they were faster. They didn't have to stop to munch on the grass. So we're taking the good one, 70 over x minus 5, take away the bad, foraging, and that's equal to the 96 hours. And you can do the math on that. Okay? So there's a few problems of each type to get you started, and we will do more problems when I get back on Thursday. Hope this helped.